In this video, we're going to look at one method for finding the nth term of a quadratic sequence. Okay, so I've got three sequences here. I can tell they're quadratic, like we said in the last video, by looking at the difference and then seeing that they all have the same second difference. So let's say I've already done that. I know they're quadratic. So now I want to know the nth term. Now, first of all, I'm just going to write out the sequence for n squared underneath my first sequence, and I'm going to compare it with the sequence I have here. So the sequence for n squared is 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. So this is my n squared sequence, and here's the sequence for which I want to find the nth term. If I think about this for a moment, I can see that my sequence here is 3 times the n squared sequence. 1 times 3 is 3, 4 times 3 is 12, 9 times 3 is 27, and so on. So my sequence here must be the 3n squared sequence. Okay, I'll come to my second sequence. I'll do the same thing. I'll write out n squared underneath and compare with my sequence. So that's 1, 4, 9, 16, and 25. If I compare my n squared sequence with my original sequence in black here, I can see that I need to add on 1 each time to get my original sequence. So my sequence here must be n squared plus 1. If we add 1 onto the n squared sequence, we get my sequence here, which is in black. Okay, third example. I've got 3, 10, 21, 36, 55. Let's do the same thing. Let's write out the n squared sequence. That's 1, 4, 9, 16, 25. Okay, now I'm comparing. So this is 2 more than 1 here. I've got 6 more here. I've got another 12 here. I can see that the pattern's not really obvious. If I times 1 by 3, I get 3, but if I times 4 by 3, I don't get 10. I'm going to try doubling my sequence here. See if I can get a bit closer to the original sequence. So let's take 2n squared. That's going to be 1 times 2, which is 2. 4 times 2 is 8. 9 times 2 is 18. And we've got 32 and 50. Okay, so this is a little bit of trial and error here. Let's compare this sequence with the sequence I've got here. So 2 plus 1 is 3, 8 plus 2 is 10, 18 plus 3 is 21, 32 plus 4, and 50 plus 5, that gets me 55. Okay, so it's the 2n squared sequence, but we added on 1 to get the first term, and 2 to get the second term, and 3 to get the third term. Well, 1, 2, and 3, those are the positions in the sequence, right? And we represent the position by the letter n. So my original sequence must be the 2n squared plus n sequence, the 2n squared plus n. So I'm really using a trial and error, trial and improvement method here, just playing around with the sequence n squared and comparing it to the sequence whose nth term I want to find.